Hi, this is Mrs. Villette, and we're going to continue exponent rules with section 5.2, so exponent rules part 2. Just as a brief review, let's talk about the exponent rules that we have so far. The first rule that we learned was called the product rule, and this states when you have two factors with the same base, you add their exponent. Next we had the zero exponent rule, which says x to the 0 is 1, except 0 to the 0 is undefined. We had negative exponents, so x to the negative n is 1 over x to the n, and 1 over x to the negative n is x to the n. This rule really just states if you want to move a factor from the numerator or the denominator to just change the sign of the exponent. Notice this doesn't make the answer negative, it just changes the sign on the exponent. So we need to learn a couple more rules. The new rule that we need to learn is called the product to power rule. And really the other rules we're going to talk about are just special cases of this rule. So the product to power rule says if you have x times y, so different bases, raised to the same power, you're just going to do x to the n times y to the n. So you have a product raised to the power, you can individually raise each factor to that same power. So as an example, if you had xy cubed, you would say x cubed multiplied by y cubed. So product to power rule. The next rule is the power to power. The power to power says if you have x to the n raised to the m, that's x to the n times m. And let's see why you multiply in this case. Let's say you had x squared cubed. Well, the outside says cube, so I'm going to do the exponents first. So I'm cubing x squared, which means I have 3 factors of x squared. And then we're just going to use our product rule, which says add the exponents, and we get x to the 6th. Notice that 6 is the product of the two exponents, 2 times 3. So let's see an example of this. Let's say you had x to the 3rd to the 5th, you would just say that's x to the 15th. Now individually all of these rules seem pretty simple. The difficulty comes in when you have to combine some of them together. So let's look at an example of combining some rules together. Let's say we had x squared y cubed to the 4th. So this requires both the power to power and product to power. So first I'm going to apply the product to power, which just says I'm going to apply that 4th power to each thing. And then I'm going to apply the power to power where I multiply the exponents. So here I'm going to do 2 times 4 and get x to the 8th multiplied by, and for the y's, 3 times 4 is 12. You don't have to write it with the multiplication, but you can just leave it how it was. So x to the 8th multiplied by y to the 12th. Okay, one more rule is the quotient to power. And the quotient to power is very similar to the product to power. It says if I have a quotient raised to a power, I can raise the numerator to that power and the denominator to that power. So let's see an example of that rule, but we'll go ahead and combine it with some of the other rules as well. So let's say you had x squared over y cubed z to the 4th. The first thing I would do is apply the quotient to power. And so I'm simply applying that 4th power to everything. Now that I've done that, I'm going to apply a power to power in the numerator and a product to power in the denominator. In the product to power, I'm doing y cubed to the 4th, so y to the 12th, and then z to the 4th. There's a special case of this quotient to power with negative exponents. So quotient to power with negative exponents. If you have a fraction raised to a negative power, I'm going to show you the long way first. You would do the quotient to power first, so a to the negative n, b to the negative n. Then the negative exponents just mean things are in the wrong place. So I'm going to take the b to the negative n, move it up. I'm going to take the a to the negative n, move it down. And when I move them, I change their exponents. So you could also write this as b over a to the power n. That's actually the shortcut that we want to use. The shortcut is that a over b to the negative n is b over a to the positive n. So if you've got a negative exponent, you simply flip the numerator and the denominator and change the exponent to positive.